This time we're supposed to calculate the frequency and period of a sine wave having a radian frequency. I have 5.4 radian frequency. The formula says omega radian frequency is equal to 2 pi f. If I want to find f, I have to divide both sides equation by 2 pi. 2 pi and 2 pi will cancel out, and I'm going to have f equals omega over 2 pi. If I want to find the period is nothing else, just 1 over f. I'm going to use these two formulas. We have 5.4 radians per second. I have to find the frequency. Frequency is equal omega over 2 pi. That's why I'm going to have 5.4 radians per second divided by 2 pi. Remember, anytime we have pi, we have radians next to it. Write always parentheses. If you are going to use parentheses in the denominator for the expression which has more than one digit or variable, you are going to avoid many problems in the future with the calculator. Radian and radian will cancel out, and you have 5.4 divided by, open parenthesis, 2 times pi, close parenthesis, on your calculator is going to be equal 0.859 hertz. Someone is going to ask why we have hertz. Please notice that the units which we have, okay, in our problem are radians per second divided by radians. Because I have radians in the denominator and I have fraction in the numerator, radians per second, I'm going to convert this radian to fraction also. Remember that fraction bar represents the division. Now I have to divide these two fractions. That's why I have radians over second. Anytime I have division of two fractions, I have to copy first fraction down, and division supposed to change to the multiplication. Second fraction has to be flipped upside down. I have to find the reciprocal of this fraction. 1 over radians. Radian and radian will cancel out. I'm going to have 1 over second times 1 over 1, which is equal 1 over second. 1 over second is equal hertz. That's why I got the answer in hertz. Remember, anytime we have frequency lower than 1 kilohertz, below that frequency, we don't use anymore any prefixes. That's why I wrote this answer like 0.0859 hertz. Next, we're supposed to find the period. Period is equal 1 over f, which is equal 1 divided by 0.859 hertz. This is equal 1.164 seconds. Someone is going to ask, how come we get seconds? Now, please realize that we have time. Time is measured in seconds. Anytime you got seconds for time means your answer is correct. But how we got seconds? Please notice that in the numerator I have 1. Anytime I have 1, I just simply write 1 over, and I have hertz in the denominator. I have hertz. 1 over hertz is nothing else, just 1 over second, close parenthesis. I have fraction in the denominator. Because I have fraction in the denominator, I'm going to convert numerator also to fraction. I have 1 over 1 divided by 1 over second. Anytime I divide fractions, I have to copy first fraction down. Division, I have to change to the multiplication. And second fraction has to be flipped upside down. Otherwise, I have to find the reciprocal of the second fraction. So that's why I have second over 1. 1 times second is second over 1. Second divided by 1 is equal second. That's why my answer is in seconds, because 1 divided by hertz is equal second. Let's take a look at the second example. I have 350 radians per second. Frequency is equal omega over 2 pi. My omega is 350 radians per second over 2 pi. Write the parentheses. Enter these numbers into the calculator and you're supposed to obtain 55.7 hertz. Remember, anytime we have pi, there is always invisible radian. So radian and radian will cancel out and we are going to get hertz. I explained that already over here. Period. Period is equal 1 over frequency. 1 divided by 55.7 hertz is equal 17.95 milliseconds. These are the answers to my problem.